In this video, we will look at some more operations that you can do with strings. So let's begin with replacement. The replacement operation allows us to replace a portion of a string with a new part for that string, or substitute part. And for this program, let's go ahead and let's bring up the editor and we'll save all the commands in a file. So we'll do the File menu, we'll do a new file. That brings up the editor, so I'll bring the editor over here, do a little resizing on it, and we'll type all of our commands in here. Now let's start out with just a comment to indicate what this is doing. And we're first going to look at the replacement. We're going to look at the replacement operation. In order to work with the replacement, then we will need a string in order to work with. So let's define a string like this. Let's say protein is just equal to, and then we'll have a string constant with a list of symbols for proteins. So let's do VLSPAD close parentheses. So this will be the string that we will want to operate with. Now, let's go ahead and print this string out. Let's do print to the screen. We'll do this a lot just so that we can see what we are working with. So let's print out the variable protein. We'll print that to the screen just as it is. Now, let's do a replacement. The replacement I want to do first is this. Let's replace all of the V's, all of the letter V, with the letter Y. So it will find all letter V's and it will replace them with the letter Y. And then we will go ahead and print that out. So let's do print, and I'm going to enclose this replace operation within the print statement, as you've seen in some previous videos. So the way this works is like this. It's protein. So we are going to use this thing called a method. So here's another instance where we're using a method. And remember, a method is something that is attached to a variable after a dot. And the method is called replace, and it has two arguments. So the first argument is going to be the letter we want to replace, which is V. Then we have a comma, and then we list the letter we want to replace V with. Okay, that'll be the letter Y. And then I'll just close the print statement. Now, let's just take this program and let's run the program and see what we get. But first of all, we need to save it. Okay, so I'm just going to do a file. I'm going to do a save as. And I'll locate my, my folder where I'm saving all of this stuff. So here's chapter 2. And this is going to be some more string operation. I'll call it strong. How about strong? Okay, strings. 2.py. So this is my second program that involves some of these string operations, so I'll just call it strings2. Then I'll save that. Now we have saved the file on the disk, so we can get it and edit it anytime we want. Now if we want to run the program, then we press the run button and it will execute all those statements. And we'll okay, so now we get some output. Now, if you look at the first line, then it has the original protein that we declared with a string constant. So it still has the V at the beginning and the V at the end. Then we run the replace operation inside the print statement. So the replace is going to find all occurrences of the V and replace them with the Y. So that's what we get when we print this out. Okay, so the Y now is in the place that V was to begin with, and over here at the end we had a V, and now that's been replaced with a Y. So that's how the replace operation works. Now you can replace more than just one character if you want to. So let's look at an example that will do that. Now I am going to use a variable this time. I'm going to call this protein new, and that's going to equal to protein dot replace, and then I'm going to replace a sequence of letters. So I want to replace the VLS with YMT. So I have the double quote VLS, comma, double quote YMT, close that, close parentheses. What this line does is it takes our original string protein that we declared up here. It replaces any sequence of letters VLS that it finds with YMT. So we do have VLS right at the very beginning, and that's the only place. So this will print out well, it won't print it out just yet. It will store the new protein with the replacement. VLS is gone, YMT will be in there. That will be stored in this other variable called protein new. Now, let's print out protein new. So print protein underscore new, and we will see what's there. Now, at this point, let's go ahead and let's print out the original protein as well. Okay, well, not protein there, print protein, and let's see what we get. And the question here is, will we get the original definition that we had at the very beginning, or is the original variable protein, which it contained that, will that be changed by any of these operations that we've done here? So one way to tell is to run the program and let's see what the output is. So as usual, we need to save, and then we run. And if I've made no mistakes, then we get this output. Okay, so let's examine the output that we have here. Okay, so that's the original protein. Then here is the case where we've replaced Y over V. And now we are replacing the YMT, I'm sorry, the VLS, we're replacing that with YMT, and then we print that out. So that's where this output comes from. And you can see the YMT now is at the beginning. It replaced the YLS. But if I print out the original protein, the last line, then I haven't changed it at all. It's still the original. So these operations that's doing a replace, they do not change the original string that we had stored here. In this example, I am saving what I replaced in a new variable. So I've got a copy with the replacement YMT for VLS, and I've got the original protein here, which is unchanged. So beware that the replace operation itself doesn't change the original thing that you have here. Now, let's move on and let's do some more examples. Let's declare another variable, okay, DNA, and this is going to be a long string of bases here. So let me see if I can type all these out. Okay, ACT, G, AAT, C, G, and another ACT there, GGT, then ACT again, and GC double quote. So that's a long enough string to work with. So we have now declared a new variable called DNA, and in that variable we've stored this long string of bases here. Now let's do an operation. We're going to do a replace, and I want to replace the ACT occurrences with something different. Okay, so now I'm going to have another variable which I'm going to call new DNA, and that's going to equal to DNA.replace. And the thing that we want to replace, this uppercase ACT, then don't forget the comma, then I want to replace it with AGT, double quote AGT, close double quote, close parentheses. Then now let's print that out. So we'll do a print new DNA, and we'll close the parentheses. Let's put a comment up here to indicate what I'm trying to do with this thing. So I'll just slip this in, and this illustrates the use of comments as well. So what I want to do is to replace ACT with AGT everywhere. Everywhere there. So that's what this statement is going to do. That will do the replacement. We'll save the replacement in new DNA, and they will print this out again. Now, let's run the program. We'll save our file and run the program. If I just click Run, then it'll ask me to save it, so I can just click OK here. and then the output shows up over here. So we've looked at the previous lines of output already, so now we just want to look at the last line where we used our DNA with a long string of bases, and we replaced a TC with a GT. Right, so back on the screen. So now we have AGT here, and we have AGT over here, and we have AGT here. So it replaced the three bases ACT with AGT. All right, so this shows you then how you can modify an existing string, and if you wanted to retain a copy of that, then you just assign it to a new variable. So now you've got the original DNA variable here that has not been changed, and you've got a version of the DNA that has a replacement AGT for ACT. In the examples you've seen so far, we've always had an equal length string for the replacement. To begin with, we had one letter V that we replaced with one letter Y. In this case, we had three letters that were replaced with three letters, and the same thing down here. Well, you may think you have to always do that, but it's not necessary. You can replace one string with a string of different length. So let's illustrate that using our same DNA sequence we had above. So let's do, I'll just put this in a print statement. Let's do a print, and we will have our DNA.replace. There's an E there, replace. And this time I want to replace the ACT as before, comma, but I want to replace it with just a single letter. So I could do that. I could do double quote and then pick the letter that I want. Let's use G, double quote, close parentheses. And then it will replace every occurrence of the three-character string ACT with just a single character G. So you may replace a string with a different length string. That is perfectly legal. So let's run this. I need to save it. And once again, I forgot to close my parentheses. Okay, so I got an error. Now we have balanced parentheses. Let's try that again. So now you can see the output. So in this last instance, I replaced the ACT that we had in the beginning with the letter G. Okay, so we had ACT at the beginning, so now we just have a G there. And then we had, I should have printed out the original, I guess, but you can see that we had the ATC that was up here. ATG is now the replacement, so I'm look for ATG. So there's ATG. There's an AGT over here. So now we have replaced that with the letter G. So everywhere we had the ATC before, then we just have the letter G. So it's perfectly legal to do that. In fact, if you wanted to, you could completely erase a section by putting in the null character. So let's do that one, and then we'll move on to a different function. So I'm going to take this print statement, I'll just copy it and I'll paste it here. And instead of replacing ACT with a character G, I'm just going to erase the G and have two double quotes next to each other. That's what's called a null string. Okay, so let's put a comment here. Replace ACT with the null string, okay, which is essentially nothing. So in effect, we will be erasing the ACTs altogether. Before we move on here, so we can see the original DNA, let's print that out as well. So let's do a print, and then just our original DNA, which is called DNA. That way we can see the original and compare it with these replacements that we've done here. Okay, so we'll run our module, we'll save the file, and then we are getting some output. So the output's beginning to get quite long here, so let's move it around like that so we can see it. So here's the original that we have, that we printed out. Okay, ACT, all that. So that's the original. And in this case, we had to replace the ACT with a G, so you can see that better now. Okay, here's ATC, and that's right after the Oh, it's hard to tell. Okay, we have ACT here replaced with a G. Then we have the next one showing up over here. And that gets replaced with a G, and so on. Now, let's look at the last one here. We want to replace the ACTs with a blank. So at the beginning of our original ACT, that's the original. Now that's gone. Okay, we have ACT followed by GAAP. So now the ACT has been replaced with a null string, essentially nothing. So ACT is gone. Then we have GA, and then we have another ATC. So that is now going to be replaced with a single with nothing as well. So that will be edited out. So you can see now that we had, if I keep my cursor in the right place, we had the GA, and then we have another, we had ATC, and then we had a G. So we had ATC, and now we have two G's. Right? So those got erased. And then finally we had this ACT over here between the T and the G. So now you see that between the T and the G there's nothing. So we erased the ATC altogether. So you can do quite a bit with these replace functions. You just have to have the string in the right position. The string has to be here, and then the replace has to be after a dot right there. And the replace function does require two strings. You have to have the string that you're searching for, and then you have the replacement string as a second argument. Now, that's pretty good for replace. Let's move on and look at a different operation we can do with strings. You can also extract part of a string if you want to. So in the previous examples, we've done some replacements, but what if you just want to take out a part of the string and save it? So this is called extract, E-X-T-R-A-C-T, extract a substring, let's call it. The way to do that, and let's go ahead and just use the original variable protein that we had up here. That's fine. We can reuse that. Then let's extract and print part of a string. So let's just go ahead and use print. Okay, D and A is the string. And then if we wanted to get part of that string, then we can, I'm sorry, we should use protein here. We'll use the protein. If we want to get just a portion of the string, then we can use this kind of notation. Use the square bracket, then use a beginning number and a colon and an ending number. Then close the square bracket and close the print statement. All right, well, what's going on there? Let's go ahead and run the program and let's see what this gives us, and then I'll come back and explain it. Okay, so we'll run it. We don't have to save it. Now, at the very bottom, you can see this prints out a P and an A. Okay, so that's the result of this statement here. Let's look at our protein string. Okay, if you go back to the top, look at the definition for that. If you count the characters, then V is 1, L is 2, S is 3, and so on as we go left to right. So each of these characters does have a position. The thing that you need to note, however, with computer science is that we begin counting with 0. So this very first character inside the double quote, that is said to be at position 0. The L is at position 1, S is at position 2, the P is at position 3. Alrighty, well, this output, this square bracket notation, where we're trying to pull out part of a string, we give it the beginning position. Okay, so 3, we want to get whatever character shows up at position number 3. So remember, we start counting at 0, 1, 2, 3, so we get the letter P. So that's the beginning part of this substring that we're extracting. We want to stop at position number 5. And the way that this works is we stop at position 5, but we do not use that character. So this says we want to extract the characters from positions 3 and 4. So we don't read the character at position 5, we stop at that. So let's put a little comment here. Okay, so let's extract the characters from position 3 and 4. So that's what this does, and then we can print those out. So it's very important to remember that you do start counting at 0. So in this case, we get this long DNA string. So this A is at position 0, C is at position 1, T is at position 2, and so on down the list. Now, given that, you can extract some characters, and of course, you can save them in a variable if you want to. So let's do that. Let's say we have a part, and let's see, protein. So let's do a protein underscore part is equal to protein, and then we indicate which part we want to get. All right, so let's suppose we want to get the D, K, and T. That's what we want to extract. So we need to know what position the D is in. So we start counting from V, 0, 1, 2, 3, 4, 5. So the D is at position 5. So that's where I'm starting. Then we have a colon, and then where do we want to stop? Well, if I want to get the D and the K and the T, I want to stop when I reach the N. So that's the way the syntax works here. We don't read that N, but we use that as the stopping point. So if the D is at position 5, this is 6, and this is 7, and N would be at position 8. Okay, so 5, and we stop at 8. And then we close the square bracket. Then we can print out our protein part. Print the protein underscore part, and this will give us those characters, characters 5, 6, and 7. So now let's run the program and show what we get. And there we have it. Okay, there's the D, the K, and the T. So positions 5, 6, and 7 are extracted from the protein string, and they are saved in protein part. So this is the way that you can literally extract some information from a string. You just give it a starting position and an ending position. Let's look at some other examples of this. So because the output's getting pretty crowded, I am going to put another print statement up here. I'll print, let's do a double quote, and we're going to do string extract. Then I'm going to use a \n, \n, double quote, and then close parentheses. So this will just print out to the screen what we're doing. We're doing a string extract and then a bunch of blank lines. Now, let's move down here and let's add some code in. What if we did this one? And let me just do a copy and paste. It'll make it much better for everybody involved. What if I wanted to print out the beginning parts? Let's do 0 through 5. Okay, what does that output? All right, now before I run the program, let's try another one. Let's do, and I'll do a Control V. I'll paste that in again. Let's do 0, and let's just go 4, for example. Now, what will those print out? We want to go from position 0 and stop at position 5, and here we'll do the same thing. We'll stop at position 4. Let's see what the output looks like. Okay, so you can see here's the output statement I made, the string extract. So now we're down here working with this extract part. So in the first case, okay, 0 through 5, how many characters will that give us? Well, it gives us positions 0, 1, 2, 3, and 4. Right? So we have V, L, S, P, and we also have the A. Right? So 0, 1, 2, 3, 4. The D is at position 5. It doesn't print that one. Okay, so we did the extract of the 0 through 5, and we get this. So if we do the same thing at the bottom, we just go 0 through 4, then we get VLSP. Now, let's continue. You do not have to get multiple characters. Let's do a print And we'll do protein. And we can get a individual character if you want to. So let's get the letter at position 2. So extract the single letter at position 2. P-O-S-I-T-O-N, position 2. So this is legal as well. So you don't always have to do the colon as part of that. So this will give us just a single letter. So let's run, and we can see the output quickly for that one. So here we see we get the letter S. Okay, so looking back at our original protein that we have up here, then position 2, that's 0 is V, 1 is L, position 2 is S, so that's how we get the S here. Okay, position number 2, which is the third character. Now, there are some shortcuts you can take with this syntax. Suppose we wanted to print everything up to character number 4. So we could do protein, then square bracket, and we could just leave that first thing blank. We could start out with a colon, and then we could put 5 as the stopping point. So let's put a comment here. What is that doing? So this will extract positions 0 through 4. So if you do leave the first number blank prior to the colon, then it assumes you're starting at position number 0. We can do a similar thing if we want to print from the end. Let's do print protein, and we want to start at position, and let's start at position 6, and then we can put a colon, and then you can just close the bracket here and then close parentheses. So this is going to extract everything from position 6 all the way to the end. Okay, so extract positions 6 through the end. So this will get all of them. So now let's show what happens with this syntax. So here are the last things that I did. So VLSPA, so that starts at position 0, and we get position 0, 1, 2, 3, and 4. So we get those 5 characters, VLSPA. So it starts at 0, stops at 5. And the last one, we start at position 6, and we don't stop until we get to the very end of the string. So in this case, we have the KT, N, and V. So if we go back to the top again, then we can count over 0, 1, 2, 3, 4, 5, 6. So you can see we get the K. And then through the rest of the string, we get the rest of the letters, the T, N, V, K, T, N, V. What if we tried to print something like this? And this is something you'll see coming up in future lessons. You can also do something weird, like do print, protein, and use a square bracket, the colon, and another square bracket without any numbers. And that's legal. And what that means is we want to print the whole thing. So we assume position 0 since we don't have a number on the left, and we assume the end of the string because we have no number on the right of the colon. So that will extract everything. Okay, so let's again just put a note here and extract the entire string. Okay, so after all of these, have we changed our protein string at all? Let's see if we have. Okay, we want to print out the protein, so let me just go grab that print statement from there, Control Copy, and I'll put this in here instead of trying to type it again. So this will type out our original string, and we'll see if we've modified it in any way. So let's run it. And here is the output. So the next to last line, how about that? Next to last line is the original. So this prints out the entire string. That's where that output comes from. Then the last statement prints out using the variable protein, and you can see it's the same as we started with. So it has not been changed at all. So we've done a lot of modifications then, or we've used a lot of functions in order to get parts of the string, but we've never changed the original value of the protein up here. We have saved some copies of it. So here we extracted some portions of the string and we've saved them in a variable, and you can always do that. So instead of just printing these out, if you wanted to save those, you just need to declare a variable and you save that part of the string into the variable exactly as we've done with that line right here. So this illustrates then how we can use these square brackets in order to remove a portion of a string. There are two more functions I want to show you in this video. So the end is in sight. We can see that coming up. But now we want to look at the count function. So counting is the count function allows us to count how many times a substring occurs. Okay, so this is going to be the count operation. So let's print that to the screen as well, since we're moving on to a new function. Print, okay, double quote. This is the count function, and we'll put a couple of \n's here to move on down the list a little bit, or down the screen. Okay, so how does count work? Count takes a single argument. So let's move our protein definition down here so we can see it better. I'm just going to copy it, and I'm going to put it here so it's close to the code. Then we can easily see what we have. Now let's suppose we wanted to count how many times a particular letter occurred. Okay, so let's use V again. Let's look for the letter V. So I'm going to make a variable. I'm just going to call it the V underscore count, and that's going to be equal to our protein dot. So here it is again. We're using the dot. So this means we're using a method. Protein dot count. And we have some variable that we're looking for, some substring we're looking for, which is the letter V. And then we close the parentheses. So this will look through our protein string. It'll look through this long string we have here, and it will count all occurrences of the letter V. Then let's print those out. Okay, print. And let's make our printout a little bit more understandable, like a little more descriptive. Okay, there are, and let's put a double quote here, and well, I'm going to put a space first. Okay, then a double quote, and then let's concatenate the count that we get. So remember, it's a number, so we need to do a string, V underscore count, and then we'll concatenate the another little string on here. So there are this many double plus sign. So there are that many letters V in the string. Okay, double quote, and then we'll close it with a parentheses. Okay, so what does this do? Okay, well, this does a count. Okay, the V count is just going to give us an integer value. How many V's did we find in this string? Then when we print this out, I'm combining several things. The string constant there are, I'll concatenate that with this integer that we have to convert to a string, so we'll get that number. And then afterwards, we'll follow it with another string constant, so we'll have a nice descriptive output. And now it works. Yay. So there are two letters V in the string. So you can see the output that we get. We get the there are, we have that nice string, and then we convert our count to a string. We print that out as the number 2. And then we continue with our sentence printing out this after the number 2. So by using the print statement, you can make your output look understandable. You can make it as descriptive as you want it to be. So count does that. Well, count can also count the number of multiple letters there are. So let's just include within our print statement without using another variable, and let's print out some of those things. Okay, so we do a print, and let's use our protein again. So we have protein, and then we have count spelled correctly this time. And let's look for the number of occurrences of some other stuff in here. Well, I don't see many repeated things, so let's look for the string, PAD. So we know there's only one. So we'll do a double quote, PAD, double quote, and then close the count function, then close the print function. So I said function, but that's a method. Anything with a dot followed by a word is going to be a method. So we should get 1 for this. So we'll run this, save it, and then sure enough we get number 1. So there's only one occurrence of pad in our substring. So count is very handy. You can count how many occurrences of a substring that you have. Now the last function that we're going to look at is going to be find. So find is similar to what you probably used with editors. It's going to find a substring. So let's just print what we're up to here. Print, okay, double quote, the find operation. So that's what we're working with next, \n, double quote, right paren. Then let's use the find function, and it is a method. So it is going to return the position. It returns the position of what it finds. So let's say we have position of the letter D, position D, and that's going to be equal to protein, and it's a method, protein.find. Then in parentheses, we're looking for the letter D. So what this will do is it will search from left to right until it finds what we're looking for. Okay, so it finds the letter D here, and it returns the position. Okay, count the positions. V is at 0, 1, 2, 3, 4, 5. So the D is at position 5. So when I print that out, we have print, then we will print out our position. Print position underscore D, close paren. So this will print the position where the letter D is located. Now, before I run this, let's do just another example, and we'll have them both together on the output. You can also look for a sequence of things. And I'm just going to use the print statement again. I've shown you that you can save the position here in a variable if you want to. But to make this a little quicker, let's just do print, and let's do protein.find. And you can look for multiple letters. Okay, so let's look for pad. Then close parentheses. So this will print out the position where the string begins. In this case, we have 3 letters that we're looking for. So what position does it return? It returns the position of that first one, the P. So that's what it's going to print out. Now, one more thing before we run it. Let's look for something that isn't in there. If I did a print, and let me just copy and paste again. Paste that in. Let's look for a string that's not in there at all. Okay, so let's look for X, Y, Z. So that's not in there. What's it going to do then? What will it give us? Well, let's run the program and let's see what we get from those 4 lines. Now, here's the result. So let me move this down, and let's look at this output. So the position D, that gives us 5, and the position for pad is 3. And look at the last one. Okay, -1. -1's not a real position. We don't have -1s as part of our string. So that's a code. If you use the find operation and you're looking for a substring that does not exist in the string, then you get this code back, -1. So it tells you, hey, I didn't find it. The number 5, we're looking for the letter D. So you can count that as well as I can. You can see that's going to be position 5. And in the last case, we're looking for the substring pad, and it begins where the P is located, and that's going to be position 3. and you can see that right there, 0, 1, 2, 3. Now, that's quite a few new operations that we've introduced. So you can do quite a few manipulations with strings. You can save the results into variables if you want to, and we have done that in this example. So I think we have gone way beyond what we should have in this video already. So I am going to terminate the video at this point. Thank you for your patience.